Hi everyone, we'll solve this problem today, which basically says that a force is pulling this block, moving it from in a smooth surface from its equivalent point at a distance of 0.12 meters, and then it's released. So the first question for our problem is, which is the spring constant? So this is a kind of easy part of the problem because we know that Hooke's law says that the force is equal to the spring constant times the distance which travels the blocks. So we only have to isolate K since we already know the force which the hand is pulling the block. And with that we'll get 100 newtons per meter. So the second question asks for the frequency of oscillations. So we already know that the angular velocity is 2 pi times the frequency. We only have to isolate this frequency, but the only problem is that we don't know omega. But we know an equation that will be useful to us, that omega squared is equal to k over mass. And we already know the value of the spring constant, and we know the mass of the object. Now we only have to substitute that variable in our equation, and that will give us 2 pi times the square root of m over k, and that will give us a frequency of 1.13 hertz. The third question is asking us for the maximum velocity at which the object can go, and where does it achieve that maximum velocity. So we know that the maximum velocity is described by the equation of the amplitude times the angular velocity, omega. And also the amplitude is given by the distance they given us of 0.2, that which is the initial position of the object. And we already know what omega is, which was of the square root of 50 meters per second. And the hard question is, where does that maximum speed is achieved? Well, the maximum speed is where the object is at the equivalent point. So that distance is equal to 0, so the maximum velocity is achieved at x equals 0. And the value of the maximum speed is of 1.41 meters per second at x equals 0. The fourth question is asking us for the maximum acceleration of the object and where does that maximum of acceleration is achieved. So we know that v and comes from x, and that gives us the acceleration. The only thing we have to do is to derivate this. So we know that the velocity equals to the mass, the amplitude times the angular velocity, and the amplitude is a constant which only gives us that we only have to derivate omega, and that will give us the acceleration at the maximum point is equal to the amplitude times the omega squared. Now, at what point does that acceleration of 10 meters per second square is achieved? So we know that the amplitude is the height of a wave. So the amplitude is given as the maximum point at which the acceleration can be at its maximum. So where we achieve the maximum acceleration is at plus minus the amplitude in this point. Now the fifth question is asking us for the total energy of the oscillation system. So we know that the total energy is defined by this equation, 1/2 of the spring constant times the amplitude squared. So we already know this and these variables, so we only have to substitute that and we'll get the result of 2 newtons per meter, which is 2 joules. The last question is asking us for the velocity and deceleration when the position equals to 1/3 of its maximum position of the object, which is of 0 meters. Now, taking from the energy equation, we can isolate the velocity. And the solution of the velocity will get something like this. And all know we know all the values, so only we have to substitute them and we'll get the velocity, the mean velocity. And you have to remember that x is equal to 0.2 over 3 because we're taking into account 1/3 of the distance. And now our velocity is of 1.33 meters per second. Now for deceleration, we have to take into account the equation of acceleration equals minus the amplitude times omega squared times the cosine of the omega times the distance plus the phase angle. And this is equal to minus the omega squared times the distance. So we only have to substitute those values and we'll get the mean velocity. But also remember that x equals 1/3 of the maximum distance. So you have to take into account that. And we'll get an acceleration of 3.33 meters per second squared. Now we are done. Ta-da!